Hello, everyone, and welcome. Thank you for joining me on this session today. This is my first tech talk ever, so very excited to be sharing these learnings with you today. So, my presentation is called Web Apps for Everyone, Everywhere, PWAs to the Rescue of People in Low Internet Areas. I'm Alicia Rojas. I'm from Chile, currently based on Mexico. I'm a natural resources engineer. Was my phone before becoming a software developer. So I developed a mixed passion between technology and sustainable agriculture, and that's where the use case that I'm going to talk about today is about. So in this session, I will be first introducing the challenge and the solution that we came for this challenge. I'll talk about browser support for some of the features, the PWS features that we used for this application and how supported they are in 2022. We will cover how to make your PWA look and feel like a native app by making it installable. And then we will dig into how to perform CRUD actions using IndexedDB and background sync. Don't worry if these concepts don't make sense still, they will eventually. And finally, we will talk about handling service worker updates and why is this important. So the challenge was a request by a client of an application that would allow to take service in areas where sometimes internet might be poorly available. This was an application thought for farmers and farm technicians to diagnose farms in the field. So it had to be an application very easy to use and share, and it should work on mobile devices. This is some screenshots of these applications. So the main feature of this app is a very complex survey with lots of questions that had to be, that the app should allow to be completed offline or where for the connection is available. So after an assessment, we came up with a solution of a Ruby on Rails application that we would enhance with PWA features, while the alternative was to develop an API along with two different native applications, one for iOS and another for Android OS. So we concluded that this option was better because it would allow us to consolidate all logic in one single code base. So it was the most cost-effective solution. The next thing we wanted to assess is how supported were the features that we were going to be needing in this application. So as you can see, all this data is taken from Can I Use. You can check in on your own. So there was clearly a compromise here on browser support, especially for iOS users, which ended up not being a big problem because most of our users were using Android phones. So in the end, it was better to just go with the PWA. And it's worth mentioning that IndexedDB is not strictly a PWA feature, but it was required for our implementation. So that's why I included it in here. So next step was to make it installable. So what does this mean is having a manifest file in our application. This is a file that is usually a JSON file. In this case, I'm using embedded Ruby, as you can see here in these tags, because it would allow me to use some Rails helpers. But the important thing here is that this file tells your browser how to behave in the context of your user OS and how to display this application. So for instance, this icon is the icon that will display in the home screen once your user installs the application following the prompt from the browser. Then we have a splash screen that really enhances the user experience by allowing like a waiting zone that it's not blank. And the other thing I wanted to remark was the standalone display that would allow the application to be displayed in a browser using a standalone window with no user interface from the agent. So this really helps giving your application a native look because it doesn't seem like it's being run in a browser. So let's dig into the main topic of this talk, which is how to make your application allow to perform CRUD actions using IndexedDB and background sync. So first things first, CRUD stands for create, read, update, and delete actions. So basically all interactions of a user with the app data and records where no internet connection is available. In this talk, I'm going to focus on create because, as I said before, the main need of our client was that this app would allow to create this service offline and then synchronize it once the connection is reestablished. So first, IndexedDB is a JavaScript API that allows to manage a database of JSON objects in our browser. This is an API that relies heavily on promises, so I really recommend having at least a basic understanding of the promises syntax. And even if you do have a strong foundation on promises, I really recommend using a wrapper to use IndexedDB. So wrappers are basically small, or well, it depends, but they're JavaScript libraries that allow to have a more programmer-friendly syntax to interact with IndexedDB, whose syntax can be a little tricky sometimes. Then the background sync API allows web applications to defer server synchronization work to the service worker to handle it at a later time when the device is offline. So if I have a diagram for this, let's suppose we have our client on one side and our server. So we're going to try to make a post request to synchronize to create a new survey while offline. This request will fail because we're not connected to internet. So what we'll do is to store this record in IndexedDB, which is this local database, as a JSON object. And once the connection is reestablished, background sync will detect this connection and will try a synchronization. And in the end, we will have our server synchronized. So how does this look in terms of code? If we think of the service worker as a small application that runs in parallel to our main application, then we have the companion, which is sort of the bridge between these two. So it basically tells your application where to install it, how to register it, under which conditions, among other things. So the first thing I considered important here was to ask whether the browser that the user is using supports these features, service worker in the first place, and the sync manager in second place. And if these features are not supported, we should prompt the user to switch to another browser that does support these features. Otherwise, it won't work. Then the next step is to actually implement the background sync inside the service worker. And for this, we use an async function that requests this sync event, which is a browser native event. So after the registration is ready, we register the event under a certain tag that is our interest. And then we add an event listener for this sync event that triggers this function if the tag matches the one that we care about. So this sync service function is where actually all magic happens. So the first thing we do is to declare this database. I'm not going to dig into these details because the syntax will vary depending on the wrapper you're using. So after you declare your database, you first query your database to see whether there exists records in this database. And then you declare this as an array. And then you declare an array of IDs of these records to be removed. Then we have, once we have our array, we will loop through this array to make requests to our server. And the important thing here is that if the response is successful, we should push the ID of that record into our arrays of records to remove. And then we handle the error if there's any. And after we loop through all records, we remove the synchronized records from IndexedDB so we don't have duplicated data. So next time background sync is triggered, it will look for this local database, and if it finds records, it will trigger the synchronization, and if not, it won't. All good. Up here, I'm gonna quickly check Discord to see if there are questions. Okay. All good, apparently. So finally, how to handle service worker updates and why is this important? So there happens to be a default behavior that doesn't allow a new service worker to take over unless all open tabs are closed or undergo a navigation. So it might be the case where you have a new service worker, but the user does not have it yet in their browser. So this might work for some cases, but in our particular case, we did wanted to have some control over this from our users, so we can make sure that our users have the most up-to-date service worker on their applications. So in order to do this, we implemented this function in our companion that prompts the user with a confirmation for updating the application. And if the user accepts the new version, then we will send this message to the service worker, this escape waiting message. So on the other side, in the service worker, we add an event listener for this particular message that will tell the old service worker to allow the new service worker to take over without necessarily waiting for these default requirements to be met. So it depends. This is one solution. It doesn't have to be your solution, but it's important to consider whether you need or not to prompt the user for installation of new updates. So some gotchas of these implementations is that first, your validations in the front end and back end must match. This is important because if you end up storing information in IndexedDB that doesn't match your backend validations, you could have errors in your request that wouldn't allow this record to be properly synchronized. So you would end up with a sort of loop where this record is trying to be synchronized, but it doesn't. So it remains in IndexedDB, and the next time it tries again, and so on. So you have to be very careful that these two validations match, so you ensure that all records stored in IndexedDB are valid for your backend. Another thing I didn't have time to cover here is that having an offline fallback is really important, because even if you're using caching or pre-caching, there might be cases where not all pages are available and you want a sensible fallback for your user, so the application doesn't drop where it finds a request that doesn't have a cached response. And the final gotcha is to understand your users, to understand the importance of the browser support that they have for the features that you required. In our case, as I said before, it wasn't really a big problem that some features weren't supported in iOS, but it might be the case that you really need these features to be supported in all devices. So it's something that you really have to assess before designing or while you are designing your implementation. So some key takeaways of this use case, this use case, is that with the appropriate implementation, PWAs really can supercharge your application and make it suitable for everyone, everywhere, as I said in the title of this speak. And there's no single way to solve a problem. So this was just one way to solve it, but you should really be curious and find your own. There are lots of resources out there on how to implement this type of capabilities. So there are some things I didn't have the time to cover. So for this particular implementation, workbook strategies were extremely helpful. So I really recommend digging into this library. It really helps to implement a very readable service worker without like really complicated code. So it's very straightforward to use. It has lots of recipes, how they call them, like easy paths for expected behaviors. Then if you're especially interested in how to implement this in Rails 7 with a particular pattern and architecture, I wrote a blog post about it. You can check it on this link. And finally, the wrapper I used, it was DexiJS. It's a very lightweight wrapper, very easy to use. It has a really light syntax, so I really like it. I recommend it. And that's it. Thank you very much. You can find me at Alicia Paz on Twitter, or that's my email. I will be answering questions in Discord if you have any. And it was a pleasure to share these learnings with you today. Thank you again, and goodbye.